I discovered a new way of how to do this, and it uses the website Desmos.com. So I'm going to type that website up at the top here for us. So it's Desmos, DESMOS.com. And if you go there, it will give you a graphing calculator that you can use on the screen, and it'll do all the shading for you, and it even helps you find the ordered pairs that are the corner points really easily. So I'm super excited to show this to you. So the first thing that you'll have to do for the questions that you have is figure out your inequality statements. Some of the questions will give you the inequality statements. So we've talked about, how the inequality statements are written, but I'm going to go through it again because this time I'm going to do it using Desmos. So a company produces 3 models of VCRs, Model 1, Model 2, and Model 3 at 2 facilities A and B. The company has orders for at least 8,400 of Model 1, at least 2,000 of Model 2, and at least 4,500 of Model 3. The weekly production capacity at each model, the weekly production capacity of each model at each facility and the cost per week to operate each facility are given in the table below. For how many weeks should each facility operate to minimize the cost of filling the orders? So what I'm going to do is kind of write the inequalities based off of the information we were provided from both the table and the written statement. And then I'm going to show you how Desmos does this so much faster for you. So the first item we have here is VCR Model 1. And VCR Model 1 has orders for at least 8,400. And the information we have for Model 1 is 700 for A and 700 for B, for Facility A and for Facility B. So I'm going to write that using, I think this morning I used red for the first one, so I'll use red again. So what we know is 700 of Model 1 are produced at Facility A, so that would be 700X, and same idea for Facility B. 700 are produced there, so 700 times Y, and that's 700 per week. And we need at least 8,400. At least is greater than or equal to, so it's going to be greater than or equal to 8,400. So there's our first inequality statement. Our second inequality statement is for Model 2. So I just switched up the color for highlighting for you because this morning I think I used pink and red for Model 1, so I just switched that. Now I'm going to use for Model 2 blue. So Model 2 is going to be highlighted in blue. It told us we need at least 2,000 of Model 2, which at Facility A is 300 and Facility B is 100. So the equation for Model 2 would be 300X plus 100Y is greater than or equal to, so once again we have that greater than or equal to inequality, and then our value of 2,000. So then we have our last facility, which was Model 3, our last model, which was Model 3, and that we needed at least 4,500 for, and we had 300 and 600 at our facility. So we're going to write our equation. I believe I did this one in orange this morning. So that would be 300x plus 600y is greater than or equal to 4,500. So the only really difficult math thing you need to be able to do when using Desmos is to solve each of these inequalities for y. So I'm going to do that on the screen. This morning I only did it for the first one, but now I'm going to do it for all 3 just to make sure everyone is definitely okay with that skill. And then I'll show you how to do the really cool stuff on Desmos. So the first equation, 700x plus 700y is greater than or equal to 8,400. So you would minus your 700x on both sides. In this case, so this is going to be 700y is greater than or equal to negative 700x plus 8,400. Then we're going to divide by 700. And because we're dividing by a positive, we do not need to flip the inequality sign, so we're okay there. So we have y is greater than or equal to negative 1x plus 12. Okay, so that's going to be the first inequality that we use in Desmos. Okay, the next one we have is the blue equation, so that's 300x plus 100y is greater than or equal to 2,000. So this inequality you're going to solve as well. So minus 300x on both sides. We have 100y is greater than or equal to negative 300x plus 2,000. And then divide everything by 100. Okay. So again, because we're dividing by positive, we do not need to flip our inequality sign. So we're okay there. And there's our second equation, and that's the same equation we got this morning. So there we go. So there's two of the three. So now I need to do the orange equation. So let me get that. We started with 300x plus 600y is greater than or equal to 4,500. And so we're going to minus the 300x on both sides, leaving us with 600y is greater than or equal to negative 300x plus 4,500. And then we're going to divide by 600 everywhere. And we will get, add another 0 there. Okay, so then we'll get y is greater than or equal to negative 1/2 x plus 7.5. And this morning I said you could leave that as a fraction or a decimal. 7.5, either is fine. Now that that's written, let's highlight it in the color that I've used for it. So I believe that was yellow. Okay, so now that we have these three inequalities written so that y is by itself, we can go to Desmos, and this is the amazing part, literally just type those in and everything will be there for us. So here's Desmos. If you go to Math Tools and Graphing Calculator, and we're going to need to kind of flip back and forth between our Word document or my Word document and Desmos. But the first equation, the red equation, y is greater than or equal to negative 1x plus 12. So what I'm going to do here is type in my equation. So just y. And if you need to get the keypad, there's a keypad down at the bottom left. If you click that, it'll come up with your inequalities. So greater than or equal to negative 1 x plus 12. So there's that. It's the first one. Then if I want to do another one, I believe our next equation was negative 3x plus 20. So I'll type that one in. Y is greater than or equal to negative 3x plus 20. So there's that one. And then my third one was y is greater than or equal to negative 1/2 x. Oops. Now notice that my x went down in the denominator. That is not where you want it, because as you can see on our screen, that is not making a straight line. So what I forgot to do is to, once I put my 1/2 in, arrow to the right so that it comes, so the cursor comes next to the fraction, then put my x, and then plus 7.5. So there are my 3. I'm going to make this a little zoomed out so we have a better picture here. And so now you can see my shaded region. If I want to make it into the first quadrant, that's when you have your equations x is greater than or equal to 0 and y is greater than or equal to 0. So that's our axes. So we have that, and I can hopefully grab the screen. And so now it's graphed for us, and you can see this darkish shaded region here to the right where my cursor is. That is our feasible region. And so our feasible region would go all the way down the y-axis here, bump when we hit the 20, arrow over a little bit, bump when it hits this point, come down, bump when it hits this point, bump when it hits the x-axis, and then follow on through. So what we need to do is we need to find those coordinate points. And so all you need to do is click on them. So if I click on a point, notice it's showing me that point. And if I double click, it will show me the coordinate. And this is the next corner point of my region. So I click it, it highlights it, and click it again, and it shows me the ordered pair. And if I click it and click it one more time, it shows me the ordered pair. And if I click it and click it one more time, it shows me the ordered pair. So those are the 4 points of my feasible region. They're the black darkened points with the ordered pairs next to them. And those are the exact points I got this morning using the calculator and a lot of work by hand. So it was 0, 20, 4, 8, 9, 3, and 15, 0. So now I'm going to go back to my Word document and write those down. So it was 0, 20, 4, 8, 9, 3, and 0, or excuse me, 15, 0, I think it was. But I'm going to double check it because I'm trying to do it from memory. So 15, 0. So let's see. 0, 20, 4, 8, 9, 3, and 15, 0. So is that what we had? Let's double check. All right. 0, 20, 4, 8, 9, 3, and 15, 0. 0, 20, 4, 8, 9, 3, and 15, 0. So now what you would do with these ordered points, or these ordered pairs, is I would take these ordered pairs and plug them into the equation that will show me which is going to do the minimum. And that's going to be my cost per week equation. So I'm going to write my cost equation, and it was cost is 14,000 for every x plus 21,000 for every y. Let me just triple check to make sure I had that right. So 14,000 and 21,000 for facility A and B, so that would be it. And then all you have to do is take those ordered pairs and plug them each in for the cost equation, and you will find which one is going to give you the minimum. So notice I'm just plugging in each of the x values to the x in the equation, and each of the y values into the y for the equation, and then I'll calculate each one of these, and I will see which one gives me the smallest cost. And the smallest cost is going to be the one that I want for my answer, so we'll just type those in and see what we get. So I typed in each of those ordered pairs, and I got my cost for each one, so I can see that the one with the lowest cost is the ordered pair 9, 3. So 9, 3 is going to be the winner. It's going to give us our minimum, and it's going to give us our minimum value. of 189,000. So there you go. That's the cool thing about Desmos. So if you want to, with your homework, go ahead and give it a try. I think it's a really valuable tool. And good luck.